Alright, so I'll bring this in my trusty guide. Alright, so I got this guide.
So, Dr. A.
Alright, so question states let G equals. Want me to write the
Should I
question?
start now?
Want me to write the question?
Yeah,
right.
where's the question come from?
Well, let me know when should I start.
Start after he's done writing. And we should all celebrate by going out and eating food.
Mm-hmm.
I think it's a good idea.
Yeah. So this is our grammar that we have to generate using our push-down automaton. Our deterministic schema. Alright. So we have to draw a push-down automaton for this grammar, okay? So you start off with the first state, obviously. So we can first accept as many negation symbols, right? So you can have like double negation, triple negation, how many negation you want, right? So you can loop that as many times as you want, okay? That says read the negation, okay? And then this thing after the comma says look at the stack, okay? This is a symbol for the stack. Look at the stack and replace it with itself. So this pretty much means leave the stack empty. Like don't change it at all.
Yeah.
So that's that. Or it can read like after a negation sign, right? You can read left parentheses, right? Or you can read a 1.
What is this automaton called again?
Push down.
The push. Can you just put it in the top there?
Yeah.
Thanks.
D.
Thanks.
Alright, so you start off with this. Now, you can read in left parentheses as many times as you want, right? Because you can have this statement right here, right? Which is valid.
Yeah.
So it says read the left parentheses and
Push the stack.
if you have anything in the stack, like this means take the stack and
Put the
push the
parentheses and the stack
into
itself.
the stack.
Yeah.
This means you push it into the stack, okay? So now, for instance,
So you push only left parenthesis.
yeah, that's all you gotta push in the stack. So now, if we use this as our example, right? So we read the left parentheses once, twice, 3 times, right? Now we're back in this state. Now we want to read a 0 or a 1, okay? So if we read a 0, do nothing to the stack, right?
Yeah.
If you read a 1, do nothing to the stack, okay?
Yeah.
So after this, you're allowed to, like in our example, after a 0, we can read a and sign, right? Mm-hmm. And after we read and sign, we can repeat everything again, right? Because we can have this as well, 0 and a bracket, and then 1, right? Blah, 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 right? So therefore, we actually loop it back to the beginning, right? Mm-hmm. So if it says, if you see an and sign, do nothing to the stack, okay? And then finally, the last 2 steps is, if you see right parentheses in the stack, okay? Take the left parentheses in the stack, okay? Mm-hmm. Pop it.
Cool.
Alright, so this is, read the right parentheses, okay? Look at the stack and find left parentheses. Pop the stack. So that popping is represented with the lambda symbol.
And if there's not already a left in there, what happens if you have too many right parentheses?
It's a crash. Because you'll see.
You'll look for it and want to find
yeah,
it.
you'll see them in the last step, right? So now you're at 2, which is the ending symbol, right? Or the end state. So now you have, this means, you know how in our Turing machines the B represented the end?
Yeah.
In push-down automatons, the pound symbol is usually the end. So for example, if we have this statement, we would have a pound symbol at the end, right? So it says if you read the pound symbol, make sure there's nothing in the stack. And then finish it up, right? So if we go through the statement, you would read left parentheses, left parentheses, left parentheses, it'll keep pushing it to the stack, right? So our stack right here Is that going to video? Yo.
Okay, I have a question, Professor Iqbal. My question, how you can, before you draw the state diagram,
Yeah.
there is a better way he was showing in the class.
Like write down the symbols and like what symbols can
Yeah.
come after each other.
So if you can make this, it's easy to draw that without any mistake.
I actually don't know that, so you have to teach me.
So you should explain.
So let's, how about us, we actually do this?
Yeah.
So yeah, let's, okay,
You-
so
you
we
know
have,
this
we
one.
have this, which looks like the answer, so we know it to be true.
So you should do that.
So why, okay,
Yeah.
so let's, is this valid?
Yeah.
Okay.
From the
So yeah, this is what it is here. So what he was saying over there is you can actually write this in this form over here, which makes it a lot easier because you can write it in the form I'm going to show you and then translate it into this. So that way you know for sure this is valid, and then you can make something after that. So yeah, so essentially. So if we're at this, I think these are all states, right? So
Pretty sure, yeah.
if you've taken in this input, you can go out to any of these. So if you're at this state where you've just previously taken in lambda, so I guess you're starting, and then you take in the first thing would be this, and then you go to another state, and that state would be this. So this of course would go to this one, right here. Is this still in there? Okay, good. Thanks, buddy. And of course you have the and sign, the bracket there, and of course you can end. Same deal, pretty much exactly the same.
Can you please explain that
About which one?
each step?
Each
How do you
step,
find
so-
F0,
So essentially,
F1?
okay, so what we can say, let's look at this logically, right? So if we have this state here, so we're at a 0, we're at a number. If we have a number, then we're going to need to be followed. This is only following by. These are all the symbols that you follow by. So if you're at a number, right, maybe you're in the middle of this. So you could be followed by the ending bracket, in which case you're the ending bracket. Or you could have simply just a 0, in which case it ends. Or you could have 0 and then and something else. In this instance, it's a number, it's the same exact case for the 1. So does that make sense?
Mhm.
If you have a beginning bracket could lead to something else. So it could either lead to, a 0, a 1, which are the two number cases. It can lead to another beginning bracket, for which case is like encapsulated. Or it could
Also
even,
not.
lead to the not, because of course you can have a not, then a number, because that can just be infinitely many, as you can see at the top. So that's that case. And then the ending bracket, so this one here, ending bracket could be, of course, it could end and then end another one to encapsulate that there. Or it could have 1, so if you, oh wait, sorry, I skipped one, it should be this. So it should be ending and then and, so you have something like this where you end it and then you and it and then add another one. And then as well, or it could be simply the ending. So maybe you finished off all the brackets like in this case and then you hit the star. So there's that case there. Another case would be, of course, the and sign. So the and sign can be preceded by, or followed by having another and sign, of course the digits as well, or it could also be followed by having a bracket because it can mean another expression. And then this one here, again, so you have and then of course you can always have another one of these, or not, and you can have and another bracket there. So we know these are all true because we can go over something like this and we can see all of these being the logical next, the following symbols. And then from there you can build an automaton that looks actually exactly like that pretty much.
And there is a way to simplify those, how many state you need.
Yeah, so it was, maybe you want to explain that.
Now there is a square bracket, you see the statements, same.
What?
Okay.
Go for it, bro. Oh, bro. Work hard, yeah.
Look at this. Those are the same. So I need one state for all of 4 of them.
Yes, that's.
And those are the same. So I need 2 state only.
Oh, okay, cool. So what you're saying is, all of these. If you notice, and actually I wrote it wrong, so that was my bad. So it makes it kind of hard to see. So do write it in a logical order that you continue to follow. So essentially sort them is what I'm saying. So sort these so that way you can actually recognize that this are all the same. So with that, so these are,
That's one state there.
Yeah.
Precisely. And if you only simplify that, so you have 3 of them. So you have 1, 2, 3. Simplify all these, for which we actually do generate that.
First
Yeah,
one.
because these two are also the same, right? These two are all the same. So
Yeah.
that's one state here, a second state, and then that's a third state. So you only need 3
Yeah.
states to
So
describe
1,
the entire
2,
compound.
3. So you have 1, 2, or no, sorry, I'll actually make it correct. So what are these actually?
Yeah, same with this one.
So this one could be, that'd be this, right?
The 4 one, or is the 0?
That's what I thought, yeah.
Yeah.
And then these 2 here
Are
are the
1.
zeros, so say 1,
I get it.
5, 6, 2. So those are all the different, so these are all the actual, there's node states there, and then these are all the transitions. So you actually link these to everything else. So if you actually were to write this first, it makes a lot more sense, it makes it really easy and concise. Verify this works by having a few test cases, implement that into an automaton.
I have a little simplified. For the first node, we can write it down like f lambda, f left parenthesis, f naught, and f and.
Oh, like to keep them all in one order. Like he wants to have all these the same one, right? after
Okay.
each other.
Oh, all the same, yeah.
Yeah, I think we're done in video, right? Like this one. You done? So we have like f lambda, f left parenthesis, f naught, and f
Oh, so you're
and.
actually going to write in the
Yeah.
names. That makes sense as well. So if you really want to see, we're going to actually now translate this into that. So we're going to alter the automaton so we can show the
F
states.
naught and f and.
Yeah.
Those are all the same, right? So this will be one state, and we have
It's a big node.
this one, and this one. These 3 are same. So it'll be another state. So this one.
This one's
Yeah, it's the same. Look at
oh,
this.
it is, yeah, you're right. I just sorted that.
So we can make another state which represent f,
Right, that's just the ending state.
f naught, f0, f1, and f left. That's the complete.
Great. And then you can see, I'll just fix this one over here. I made a mistake. So yes, so my mistake, this should have been, for which this is again state 1. So all of these,
So the only thing we actually need is just 2 states describing the entire this
Yeah.
thing right here, and
Only
then
2
one
states.
last state for the ending.
yeah. So it really simplifies it down. So if you do this first,